Dundigal. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about bus and memory transfers. So, in the bus and memory transfers, it is related to bus and memory of transferring of CPU. So, a more efficient scheme for transferring information between registers in a multiple register configuration is a common bus system. A common bus consists of a set of common lines, one for each bit of a register. Control signals determine which register is selected by the bus during each particular register transfer. So, different ways of constructing a common bus system using multiplexer, using tri-state buffer. So, when we are using the CPU, in the CPU there are ALU, memory unit, and control unit will be there. It is a control unit and it is a memory unit. So, when we are going for the control unit and the memory unit, so it is the interfacing between the bus and memory. So, bus means there are address bus, data bus, and control bus. So, address bus registers are different, data bus registers are different, and control bus registers are different. So, it is related to, suppose we have the data is there, I have to transfer the data from one memory to the another memory. So, what we need a memory and a bus to transfer the data. So, data is transferring. So, what we need, data is transferring means we need a memory and we need a bus. So, bus is transferring the data from one source to destination. Okay. So, what we need means I need a memory. In a particular memory, the data is there. So, in that address, in that memory, we have to capture the data and we are copying and we are transferring to the destination. So, it is the efficient scheme for transferring information between registers in a multiple register configuration is a common bus system. And common bus means same memory. In the same memory, the data is transferring in a same memory. That is a common bus system. So, in the common bus consists of a set of common lines, one for each bit of a register. And control signals determine which register is selected by the bus during each particular register of the transferring of the memory. So, different ways of constructing a common bus system. So, common bus system for source to destination, we are transferring the data from source to destination. I need a bus to transfer the data. So, how we are constructing a common bus system? So, using multiplexer and using tri-state buffer. So, multiplexer is a one method to transferring the data, and tri-state buffer is another one. So, memory unit is there. In the memory unit, already in this bus and memory is there. So, in the memory system, I have to transfer the data. So, read and write operations are there. So, read and write is transferred to the memory. It is a memory address register, MAR, and a memory buffer register, MBR. So, suppose I have to transfer the data from source to destination. So, what I want to transfer? I want to transfer the data. So, from source to destination means we need memory or not? Yes, I need a memory to transfer the source to destination. So, if I am transferring means read operation or write operation. Okay. So, at the source side it is read, suppose. At the destination side it is a write. So, suppose source side it is a read, it is a write. Suppose I am taking it is a write and it is a read operation. So, are you reading or writing operation? Means are you transferring from source to destination or reverse order. So, read operation is going on or performed. Read means from the memory to another one. Write means to the memory. So, here you can see here, write means to the memory unit. Read means from the memory unit. So, from the memory unit means it is memory unit to outside. Write means to the memory unit. Okay. And memory address register. So, memory is there and in the data is there. So, data is there in the memory in which area? That is called address. Okay. Suppose it is a memory. There are so much data is there. So, where is the data? My address, my data, where is it? Suppose this address name is 01, 0, 1, 0, 0, 1, 1, 1, 0, like this. So, here the memory is there. In this memory, there are so many memories are there here. It is one particular data. Here also data is there. Here also data is there. Here also data is there. but there are so many data are there. So which particular data you need to read operation, to perform write operation? Means in the particular address, in the particular 01 address, what is the data that is the I need to copying or to transfer the data. So that is called the memory address register. So in the memory, there are so many addresses are there. You have to choose one particular address to copy the particular data. So that is a memory address register. Okay, after capturing the finding the address, 01 address is there. In this address, what is the data? What is the data? This data is belongs to memory unit. So this memory is transferring the read operation or performing write operation, or memory buffer register. Buffering means it will be buffering from the memory. It is buffering from the memory and it is capturing the data of particular data of the particular address. Okay, it is about the bus and memory transfer. So in the source to destination, source means it is also one memory unit, and the destination also we need some memory unit. Okay, so in the source to destination, in the memory, what is the particular address? There are so many slots will be there. So address is 10, 01, 11, 100 like this. Okay, I need memory address register, and I need memory data register, and I need memory buffer register to transfer the data. I need to transfer the data, memory address register, memory data, memory buffer register to transfer data from source to destination, or read to or write performing read and write operations. Okay, that is the MAR, memory address register. So buffering means it will be buffering the memory, and after the buffering, it will be taking the capturing the data from the particular address. Okay, it is sent to that destination. Okay, so source to destination means I need source to destination, I need bus, and I need data. Data is nothing but a memory. So bus is transferring the data from source to destination at the particular data in the MB or KB or like in the bits, in the bits like this, 8 bit, 16 bit like this. So in that common bus system using multiplexer. Okay, already we discussed there are two types are there, using multiplexer, using tri-state buffer. So what about the multiplexer? So common bus system using multiplexer. The multiplexer select the source register whose binary information is then placed on the bus, and the following block diagram shows the bus system for 4 registers. It is constructed with a 4x1 multiplexer, each having 4 data bits, 0 to 3, and 2 selections from S0 and S1. Okay, so I am taking the multiplexer, that is MUX. Okay, in this multiplexer, select the source register whose binary information is placed on the bus. Okay, source to destination, how many input lines and how many output lines are there in the multiplexer. Okay, so here how many are there means here 4 inputs are there, only 1 output is there. So I am taking 4:1 means 4 input lines, one output line. So a multiplexer select the source register whose binary information is then placed on that one. So here I am taking 0, 0, 1, 1, 1, 0 like this. Okay, so binary information is taking the multiplexer as the input, and the following is the bus system for 4 registers. 4 registers means 4 input registers constructed with the help of 4x1 means 4x1 means 4 inputs, only 1 output. So that is called the multiplexer. N number of inputs, only 1 output. That is a multiplexer. N inputs, 1 output. So it has the 0 to 3, 0, 1, 2, 3 like these selections lines are there, and 2 selection inputs S0 and S1. So here I am taking, suppose I am taking here multiplexer, 4 input lines are there, only 1 output. So I am taking 0, 1, 2, 3. So 4 input lines. S0 and S1 are the selection lines. So S0 and S1 are the selection lines. So 4 into 1 multiplexer, each having the 0 to 3 and 2 selection lines, S0 and S1. S0 and S1 are the selection lines. Suppose I'm taking S1, S0 means maybe the switch is off, S1 is switch is on, like this. So here 4:1 multiplexer. So here ABCD are the inputs and taking the logic gates with bus lines of bit 0. So 2 into 4 means 2 input lines and 4 output lines are there. Decoder means 2 inputs, 4 outputs. Okay. So how many inputs are there? 0, 1, 2 inputs are there. So these are the inputs. How many outputs? 4 outputs are there. So these 4 outputs are the inputs of a multiplexer. Okay, it is a mux. It is a multiplexer. So how many inputs are there? 1, 2, 3, 4. 0, 1, 2, 3. Or how many outputs are there? 1 output. Okay. So this I am taking as a 0, 1, 0, 1 as the inputs. Okay. Maybe we'll get the output is 1 or 0. So bit 0. Bus line of bit 0. So how many inputs are there? A, B, C, D are the inputs and 1 output line. So it is connected to the decoder. So how many selection lines? Decoder 2 into 4 means 2 inputs and 4 outputs. Okay. It is a decoder of 2 inputs and 4 outputs. These are the selection lines and it is a bus line with 3-state buffer. It is about the 3-state buffer. 0, 1, 2, 3-state buffer. Okay. So decoder is connected to multiplexer and multiplexer output is 1. So here also a dual bus architecture. The main memory is here I'm taking main memory. So main memory is connected to the CPU. How many are means? Data bus, address bus and control bus. Okay. CPU to input output, data bus, address bus and control bus. So in the previously we discussed memory is connected to CPU. It is connected to input output lines. Input output lines means peripherals. So how we are transferring the communication between memory and CPU means we have 3 addresses are there. Data bus, control bus and address bus. Here also like this 3 buses are there. Data bus, control bus and address bus. So 3 buses are communicating, memory to the CPU and CPU to the input. So input to CPU we can't access directly, through the CPU only it is possible to connect. Here also memory and between the input output we are definitely connected to the CPU. So CPU is interconnected with data bus, address bus and control bus. Here also data bus, address bus and control bus. So these buses are interconnected to the main memory and CPU, and these 3 buses are interconnected to the CPU to the input output devices. Okay. So it is about the memory and bus system. Okay. Bus and memory transfer are very important role for the transferring of data from source to destination or from one memory to the another memory. How we are using means through the buses, data bus, address bus and control bus. And memory means we are using main memory or peripheral or secondary memory we have to use. But if I am taking secondary memory means definitely I need input output devices to connect into the CPU. Okay. When I am using secondary memory, definitely we need CPU to connecting the input output devices. Then only we have to show secondary memory. Okay. So main memory to the CPU, data bus, address bus and control bus. CPU to input output means data bus, address bus and control bus. It is about the dual bus architecture. Okay. Here another example of bus system for 4 registers. Okay. It is register 1, register 2, register 3 and register 4. Okay. 4 into 1. What is a multiplexer? I am taking mux 0, mux 1, multiplexer 2, multiplexer 3. How many are there means 4 selection lines are there. 4 into 1 means 4 input lines are there. We can see here 4 input lines. How many output lines means only 1 output. Okay, it is 1 output. 4 inputs. Okay, so 0, 1, 2, 3 are the 4 registers, 4 inputs. D0, D1, D2, D3. In the bus system, 4 registers are there. that is a D0, D1, D2. Here A0, A1, A2, A3, register A, register B, register C, register D. How many registers are there? 4 registers here we are taking. So in the 4 registers, how many inputs are there? 4 registers, 4 inputs are there. So 4 inputs, 1 output. 4 input registers, 1 output register. Okay. So here register 1, 2, 3, 4. These are the 4 lines. Each have 4 lines. Each have 4 lines. 4 lines. 4 lines. So at a time only one multiplexer have to be activated. Suppose here I am taking A0, A, B, C, D. At a time 4 are not possible. If I am taking D, one line is from D, one line is from C, one line is from B, one line is from A. So how many are there means A input 1 line, B input, C input, D input. How many are there? 4 input lines, only 1 output line. Here also I am taking A2 line, B2 line, C2 line and D2 line. How many are there? Only one input from each register. Okay, each register only 1 bit only possible. So here D0 is given to the the first register. Here D3 is given to the D3 third register. C2 is given to the second register. Okay, C1 is given to the C1 register. 0 is given to the A0 register. So each multiplexer having 4 inputs, but each register is supplying the one input line to the multiplexer. We getting the 1 output line. Okay, 4 input line and 1 output. So S0 and S1 are the selection lines. Selection lines. So in the 4x1 multiplexer, we are giving the selection lines are S0 and S1 are the selection lines, 4 inputs and 1 output. It is a 4-line common bus. And the 2 selection lines S0 and S1 are connected to the selection inputs of all 4 multiplexers. The selection line choose the 4 bit of one register and transfer them into the 4 lines of common bus. When both the selection lines are low logic, that is S0, S1 equal to 0, 0, then 0 data inputs of all 4 multiplexers are selected and applied to the output buses, and the turn it causes the bus lines to receive the content of register A, since the outputs of these registers are connected to the 0 data input of the multiplexer. So in this multiplexer, majorly we have to discuss about the 2 switching lines S0 and S1. So here 2 selection lines S0 and S1 are connected to the selection inputs of the 4 multiplexers. These are the 2 selection lines which are connected to the how many multiplexers? Which are connected to 1, 2, 3, 4, which are connected to the 4 multiplexers as a inputs, and the selection line choose the 4 bits of one register and transfer them into the 4 lines of common bus. When both of the select lines are at low logic, S0 and S1 equal to 0, 0, the 0 data input of all 4 multiplexers are selected and applied to the output that forms the bus. Okay, so these selection lines S0 equal to 0, 0, then 0 data input, that is called 0 data input, and multiplexer are selected and applied to the output of that form. Okay, 0, 0 means 0 input and it is connected to the output line, and it is causes the bus lines of receiving content of a register A. The output of this register is connected to 0 and the inputs of the multiplexers are connected to the output line. Similarly, S1 S0 equal to 0, 1, the register B is selected. Register B is selected when S1 S0 equal to 0, 1. S0 S1 equal to 0, 1. Register B is selected. And the bus lines will receive a content provided by a register B, and the following function table shows the register that is selected by the bus for each of 4 possible binary values of the selection lines. So here I am taking S1 S0 equal to 0, 1, S1 S0 equal to 0, 1. If 0, 1 means B selection line. Okay, if I am taking 0, 0 means A selection line. Previously we discussed. 00 means A selection line. 10 means C selection line. 11 means D selection line. How many selection lines are there? 4 selection lines. So for 4 selection lines, how many registers I need? 4 registers we need. A register, B register, C register, D register. So 00 means A. So if I am taking 00 means selection line is A, 01 means selection line is B, 10 means selection line is C, 11 means selection line is D. So how many selection lines are there? A register, B register, C register and D register. A register is for 00, 01, 10, 11. If I am taking selection lines are 00, A register is selected. If I am taking selection lines are 01, B register is selected. 10 means C is register is selected. 11 means D register is selection. So like this we have to register selections of S0 and S1 for the multiplexer. And the second one is a common bus system using tri-state buffer. The 3-state gates can be considered as a digital circuit that has 3 gates, 2 of which are signal equivalent to logic 1 and 0 as a conventional gate. However, the third gate exhibits a high impedance state. The most commonly used 3-state gates in a case of bus system is buffering gate, and the graphical symbol of 3-state buffer can be represented as it is a normal input A, normal input C, output is Y. So here when Y equal to A, if C equal to 1, Y equal to A when C equal to 1. If it is 1, then only A equal to Y. So input equal to output. When C equal to 1, high impedance of C. C0 means high impedance. So the 3-state gates, how many 3-state means 1 input, 1 output and normal input is C, considered as a digital circuit that has 3 gates, 2 of which are signals equivalent to logic 1 and 0 as an conventional gate. However, the third gate exhibits a high impedance state. The most commonly used 3-state gates in case of a system is buffer gate. So the graphical symbol of a 3-state buffer gate can be represented as a input A, output Y and input is C. Y equal to A when if C equal to 1. High impedance is C equal to 0. And the final diagram of demonstrate the construction of a bus system with a 3-state buffer. Here I am taking A, B, C, D gates are connected to bus line of 0. How many are there? 2 into 4 decoder means 2 selection inputs, 4 output lines are there. So 2 selections means I am taking S0 and S1. Output means 00, 01, 10, 11. So if I am taking input lines are 3, I am taking A into B are the inputs. It is a enable. Okay. If enable equal to 0 means no inputs and no outputs. If enable equal to 1 means the switch is on when inputs are 00. It is a 0001 and here inputs equal to 01, then it equal to 01, 10, 100, like it is like a step size. It is like a step. So I am taking like this enable. It is a switch enable 0 and 1. Only 2 conditions are there. Enable equal to 0 or enable equal to 1. Only 2 conditions are there. So here I am taking 00, 01, 10, 11. 00, 01, 10, 11. 4 conditions are there. For this condition 1, 00, what are the outputs? 0, 0, 0, 1. 0, 1 means 0, 0, 1, 0. 1, 0 means 0, 1, 00. 1, 1 means 1, 000. Like this. Okay. So the outputs generated by the 4 buffer registers are connected to form a single bus line. Only one buffer can be active state at a given point of time. The control inputs of the buffer determines which of the 4 normal inputs will communicate with the bus lines. A 2 into 4 decoder ensures that no more than one control input is active at any given point of time. So, how we are transferring the memory? The most of the standard notations used for specifying operations on memory transfer are stated below. The transfer of information from a memory unit to the user end is called a read operation. The transfer of new information to be stored in the memory is called a write operation. And a memory word designed by the letter M, we must specify the address of memory word while writing the memory transfer operations. The address register is designed by AR and the data register is by TR. So how we are transferring the memory? So first one, the transfer of information from memory unit to the user end is called read operation. Memory to the user end. It is the transfer of new information stored in the memory is called write operation. I am taking new memory to copy to store the memory. That is a write operation. So it is for read and it is for write operation. And a memory word is designed by the letter M. Any type M is nothing but a memory. We must specify the address of memory word while writing the memory transfer operation. The address register is designed by AR, address register, and the data register is DR. Address register AR, data register is DR. We are specified in the memory. And read operation can be stated as DR tends to M of AR, means memory of address register of the data register. In the memory, suppose in the particular address, that is a 01 and it is a 10 example. In this 01, the data 1 is there. Here the data 2 is there. Suppose memory of address register means in the 01 address, what is the data is there? That is a data register. So it is the DR, and it is a M of AR. M of AR tends to DR, means memory of address register to the data register. So memory of address register to the data register. The read statement causes a transfer of information into the data register DR from the memory word M selected by the address register AR, and the corresponding write operation can be stated as M of AR tends to R1. The write statement causes a transfer of information from register R1 into the memory word M selected by address register AR. Okay, address register to the memory unit, it is a read and write operation, and the data out and the data in is there. So memory of address system is in the particular address, the data is copied to the DR and it is a read. When I am going for the write means, what is the data in R1? What is the data in R1? What is the address? This register data is copied to in the particular address, that is a M of AR. So it is M of AR to the data register, that is read. Here data to the address, that is a write operation. So the write statement of a transfer information from R1 to memory is selecting from the address register AR. Data in and data out. So memory transfer. Memory transfer simply mean to a transfer from a specific location of memory to a register. However, a memory transfer can either ways, it can work either from memory to register or from register to memory. A transfer from memory to register is called read, memory to register is read, and register to memory is called write. It is very, very important. Memory to register is a read operation and register to memory is a write operation. It is about the memory transfer and it is simply mean to transfer from a specific location of memory to a register. And the memory transfer can be either ways. It can work either from memory to register or register to memory. It will depending on we are memory to register or register to memory. It will be completely to about read and write operations. Here it is one example of the first instruction depicts transfer of value 377 to your register AR. The value 377 to AR means address register. This data is copying to the address and the basically address that is stored in address register AR, and the second instruction transfer the value of 377 from memory to register. Memory to register. So register is R1, that is a 68. So 377 is data. Yes, this 300 data is copying to address register. So after that it is called R1. It is tends to M of AR. In this register R1, what is the value is there? The 68 value is there in the register R1. So 378, 377, these are the address lines are there. These are the address and it is a data. So address plus data equal to memory. it is a memory read operation. So in this memory read operation, first searches for a location in the memory, then transfer the value located to the location to a register. So 377, the value is copying to the particular address, and this address is belongs to the one particular register R1. So what is R1 value here? 68. So the address register is M of AR is a 68 value is there in the particular address. What is address means? 377. Okay, in the 377 address, what is the value? 68. So address I am defining as a memory of AR, and the data I am defining as a data register or R1. Address is defining as M of AR, memory of address register. Data, nothing but suppose 68 is value. Example, 68 is value. This data I am taking as a register or R1. Okay, in the R1 register, what is the value is there? 68. R1 register 68 is there. But what is the address of this one? Suppose this address is a 377. Okay, M of AR tends to DR, means in the particular address, what is the value? DR. So in the 377 address, the value is 68. In the 377 address, the value is 68. Memory write operation. A memory write operation simply extracts a data from a register and transfer it to a memory location. So here 68 value is belongs to R1. In this R1 register, the value is 68 is there. But what is address of this one? 377 is the address, that is the AR. So M of AR means in the memory of address register. In this address register, the R1 is the data value is there. So in the 377 address, the 68 value is there. So 377 is the address and 68 is the value stored in register R1. So M of AR tends to R1 means in the R1 is nothing but a register. What is the value of register? Here the value of 68. The value of 68 is stored in this register. The register name is R1. The register name is R1. So what is the use of register means? To store the data. What is the data? 68 value is stored in the register R1. Okay, that is called DR. And what is the address of the register R1 means? AR, address register. So M of AR means in the particular memory, what is the address of the 68 value? The address of the 68 value means M of AR. The address of the particular data. The address of the particular data or the address of the particular register. That is the M of AR, memory of address register. Okay, it is about the write operation. So these are the references. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.